Hi, I am Virendra and I am presenting to you my machine learning project on power plant energy prediction. The project aims to predict the net hourly electrical energy output of a combined cycle power plant. The dataset contains more than 9,500 observations with the following features: temperature, exhaust vacuum, ambient pressure, and relative humidity. Since we are predicting a continuous numerical value, that is the output in megawatts, this is a regression problem. The modeling approach that I have taken is I am testing three regression models as follows. First is the linear regression. This is a baseline model and it assumes that the data is linear. The next is the ridge regression. This is a regularized model and it prevents overfitting. And finally, I am also using random forest regression. This captures non-linearity and if there are any feature interactions. Evaluation matrix that I have used are as follows. In the validation phase, I am using mean squared error as it penalizes large errors more than the mean absolute error. And in the final test phase, I am using the mean absolute error and the R squared score. I split the data into three sections. First is the training set, which is the 60% of the test data provided. Then 20% is for the validation set. And finally, the last 20% is for the test set. I trained all three modules on the training set and evaluated them using the MSE on the validation set. The Python output of the validation result is as follows. Linear and ridge regression have performed identically, indicating that there is little impact from regularization. Their MSE values are 19.89. Random Forest had the lowest MSE, that is 11.29, and it is suggesting that the data is nonlinear. So the best model that could be chosen from this is a random forest regression. I fine-tuned the hyperparameters using GridSearchCV, which is provided by the Python library. Post tuning, I evaluated the random forest on the test set using MSE, MAE, as well as R square. The test result is as follows. Mean squared error is 12.30, mean absolute error is 2.48, and the R square score is 0.96. What this basically means is the average prediction error is plus or minus 2.48 megawatts. It also means that 96% of the variance in power output is explained by the model. So this confirms there is strong generalization to unseen data. The graph on the left-hand side shows the actual value versus the predicted value. The red dashed line is for the perfect predictions. And as we can see, model predictions are closer to this predicted line. On the right-hand side, we see a residual plot. The random scatter around zero confirms that model has no systematic bias. To conclude, random forest has performed best in this situation. The hyperparameter tuning achieved the mean absolute error of 2.48 and the R square score of 0.96. The model effectively predicts power plant energy output and it generalizes well. As far as next steps, fine tuning of the hyperparameters further would help us in making the model better. Feature engineering to include additional environmental factors. And finally, deploying this model in real time power forecasting systems will definitely give us better results. Thank you.